Question number 11 is another rational expression one, and I do want to factor this. So the denominator is a difference of two squares. That'll be x plus 2, x minus 2. The numerator, I'm not going to really factor it, but if you do want to write it as x plus 5, you can. You don't have to. Really, we're just looking for where this is 0 or undefined. So this is x is equal to negative 5, and the other one will be the same. So if you can just look at the original one, then you don't need to split it up. But the bottom will be x is equal to negative 2, x is equal to positive 2. So on my number line, those are going to be my cutoff points. So negative 5 is going to be a normal cutoff point, and 2 and negative 2 are going to be undefined cutoff points. So I'm going to put them in a different color. And let's check to make sure that those are my correct cutoff points. So if you type, again, make sure to put a parentheses around the numerator and denominator. If you type that into y1, then you'll see that negative 5 gives you 0, negative 2 and 2 both give you error. So that is a confirmation that those are the cutoff points and the undefined cutoff points. So then if you pick numbers in between those regions, or I should say in between the cutoff points, they're within the regions. I picked negative 6, negative 3, 0, and 3, but you could pick different numbers. You get a positive number, a negative number, and a positive number. Okay, so which regions do we want to include in our answer? This is greater than or equal to 0. So we want the positive regions and where it's equal to 0. So that's going to be here, here, and here. So I'm going to go all the way up to negative 2. That's going to be with a parentheses, whereas these were brackets. And then union, parentheses, 2, and infinity. So this is one way to write the answer. Again, make sure that you put a parentheses around negative 2 and 2 because they're undefined cutoff points that can't actually reach there, even though we have the greater than or equal to. But if you notice here, this says that our answer goes from negative infinity all the way up to negative 5, including negative 5, and then picking back up at negative 5, including negative 5, and going all the way up to negative 2, and we don't include negative 2. But there's really no gap here, meaning negative 5 is defined there. So if you wanted to, you could express this as negative infinity all the way up to negative 2, because this means the same thing as this, meaning there is no break. At negative 5 it is defined there. So instead we could represent these two intervals just as one interval, and it would mean the same thing. I do still need to put the other part of the answer there too. So this or this would be your answer. So again, any numbers within these regions make the original inequality true.